Okay, this is another question from the 422 quiz. This was the extra credit one. I'm going to go over this. Now, I made kind of an error when I did this video at first, so I'm going to redo it so you don't get kind of bogged down on that error that I made. So I made a correction on this, but it was a while, so I don't want to I don't have to worry about you seeing that and wondering too much what's going on. So I kind of redid this. So this is already written out, so I'm just going to kind of cover it up and kind of go over step by step. But this, first of all, this was the extra credit problem, g of f of x. So let's take a look at this. And like I said, I already did the work, so I'm just going to go over step by step and kind of cover it up here so you can see what's going on. So we want to find g of f of x here. All right. And so my g rule was g of something equals that something squared minus 2 times something minus 3. Remember, that was the g function over here, which was x squared minus 2x minus 3. So x squared minus 2x minus 3, that was my rule. And then I want to find g of f of x, so every time I see the blank, I put the f of x, because that's what we're looking for, g of f of x. But what was f of x? And remember, if this is going too fast, you can always pause it and think about it. There's nothing wrong with that. So this is going to be 5x plus 4 squared, 2 times 5x plus 4. So every time I see an f of x, I put what f of x was, and f of x was 5x plus 4. Now this is where it's tricky because I have to square this out. So when I square this out, this really means 5x plus 4 times 5x plus 4. So you want to write that out, because lots of times people will just square we'll square these two terms and forget about the middle term. Okay? And this is a shout out to one of my students, Joy. So he knows I'm working for him here. Anyway, so this is going to be 5x plus 4 times 5x plus 4. Now I can remove this parentheses because there's not much to do. That's going to be a negative 10x, and a negative times a positive is a negative. 2 times 4 is 8, and then I got the negative 3 over here. And then we can multiply this out, so we use the FOIL process. 5x times 5x is going to be 25x squared. Then I've got my outside and inside terms, and those are the ones sometimes we forget. 4 times 5 is 20x. 4 times 5 is 20x. 20x plus 20x is 40x. And then 4 times 4 is 16. Then I've got my negative 10x, and negative 8, and negative 3 is negative 11. And then I can finally simplify these all together. This is going to be 25x squared. 40x minus 10x is 30x, and 16 minus 11 is 5. So there's your g of f of x. So again, you could pause that, make sure you follow that. You can always write it out and try it again, make sure you understand what's going on. So that was the extra credit problem. That was a little more difficult. Okay, and then I also told you on a future quiz we may have a problem like this because we didn't really cover these too much in class. And this is just multiplying f by 3 and g by negative 2. And we can combine them. And when you multiply a function by a constant, you just multiply each term, so it's very simple. So 3 times f of x minus 2 times g of x. What's f of x? Well, f of x was 5x plus 4. What's g of x? That was x squared minus 2x minus 3. And then we just distribute out and simplify or combine like terms. So it becomes, again, like an algebra 1 problem. 3 times 5 is 15. 3 times 4 is 12. So that's 15x plus 12 minus 2x squared. A negative times a negative is a positive 4x. And a negative times a negative is a positive 6. And then we can combine like terms. Negative 2x squared is the only x squared term. 15 plus 4 is 19x. 15x plus 4x. And 12x plus 6 is 18. So I hope that makes sense. So that was another type of problem we might see. And one other one I mentioned, and it's kind of what we use composite functions for, and that's to identify functions that are inverses of each other. So this is an example. And I've got two functions here, f of x and g of x. Are they inverses of each other? Okay, so we're not too sure. So let's go on one side and let's see. So let's take a look over here. So if they're inverses of each other, this would be what we want to show. We want to show that f of g of x is x and g of f of x is x. Then that means they would be inverses. So we want to show that the composites of each other are both x. So let's work on this one first. So let's find f of g of x. So again, it's a composite function. So the f function, f of something is 5 times something plus 4. And that something is going to be the g of x. So f of g of x is 5 times g of x plus 4. And then I can, every time I see a g of x, I'll put x minus 4 over 5. So that's what g of x is, x minus 4 over 5. And then I just simplify it. And 5 over 5 becomes 1, so I just have x minus 4 plus 4, which is just x. So that verifies that part. Now I've got to check the other side because it has to be both ways. F of g of x and g of f of x. So over here, g of f of x, well, the g rule is something minus 4 over 5. So g of something is something minus 4 over 5, so I put a bracket there. But what is that something? That something's going to be f of x. So g of f of x is f of x minus 4 over 5, based upon that rule. But what was f of x? F of x was 5x plus 4. So 5x plus 4 minus 4 over 5. And then I simplify that. Well, if I remove the brackets, I just can't have 5x plus 4 minus 4 all over 5. And that is a 4. A little sloppy here. But what's 4 minus 4? That's just 0, so I just end up with 5x over 5, and 5 over 5 is 1, so I just end up with x, so that verifies. Oops, there we go. So that's how you would verify that two functions are inverses of each other. Show that if we take f of g of x or g of f of x, in each case we get x. And in each case we did get x, so that means that these functions are inverses of each other. Okay. And I've got one more part, a little graphing problem, and I'll show you that in part 3.